So we start at 3 for this graph at 0, because cosine of 0 is 1 times 3 is 3. Then pi over 3 is a half. Cosine of pi over 3 is a half times 3 is 3 halves. So I'm going to descend all the way till I hit the minimum, which occurs at pi. And then I'm going to ascend all the way until I hit the maximum, which is 2 pi, counting by 1.5s here. I'm going to start descending again all the way until I get to 3 pi, which is a min. And I'm going to start ascending again until I get to 4 pi, which would be the max. As I said, the table, I don't really think those are that hard to do. Once you have the first two values, you're done, just by counting at that point. Now, the graph itself, yes, this is not an easy graph to do. You got to be really, really careful with what's going on. So let's take a minute to graph this out. So remember here, I'm graphing our theta in this case. So 0, 3. Pi over 12 is labeled 3 halves. Just estimate to the best of your ability. Pi over 8 is the pole, which should make sense. Roses go through the pole a ton. Pi over 6 is negative 1.5. Pi over 4 is negative 3. Pi over 3 is negative 1.5. I mean, you already start to see 2 of these petals go. 3 pi over 8 is back to the pole. 5 pi over 12 is 1.5. Oh, there we go. Pi over 2 is 3. There's my third petal. 7 pi over 12 is 1.5. 5 pi over 8 is the pole, who cares? 2 pi over 3 is negative 1.5. So 2 pi over 3 will be 5 pi over 3. 1.5 is right here. And now, yes, this does start to get cluttered because there's a lot of dots just everywhere. 3 pi over 4 apparently is negative 3. So that's going to be right here. There's my, there's another petal. I see 1, 2, 3. I already see 4 petals. Half the graph's already done. 5 pi over 6 is negative 1.5, which should be right here. What else do we have here? Pole. 11 pi over 12 is 1.5. And pi is 3. So I already have 5 poles, or 5 petals right now. Now let's use polar axis symmetry here. So let's start with the petals and work our way inward here. So there should be a petal at pi over 2, which means there should be a petal at 3 pi over 2. There's a petal at 7 pi over 4, which means there should be a petal at pi over 4, which this would be the third circle right here. And there's a petal at 5 pi over 4, which means there's a petal at 3 pi over 4. There's your 8 petals right there. 1, 2, 3, 4, 5, 6, 7, 8. So I know at least the tips of all my petals are there. Now I got to fill in the intermediate points. Basically, every point, so pi over, let's just go around the circle here. Pi over 12 should map to 23 pi over 12. Then 5 pi over 12 should map to 19 pi over 12. Then 7 pi over 12 should map to 17 pi over 12. And 11 pi over 12 should map to 13 pi over 12. 7 pi over 6 should map to 5 pi over 6. 4 pi over 3 should map to 2 pi over 3. I already have that one. I already added that one. So 5 pi over 3 should map to pi over 3. And 11 pi over 6 should map to pi over 6. Now connect the dots. Easier said than done, for sure. I even lost myself in this graph second hour, so let's see if we can make this work here. It starts at 0 and goes to pi over 12. Because second hour I fought the hand and then I lost it. So if you don't fight the hand, you're good. Remember. I'm serious. Goes down. Oh, sure, I completely missed the pole there. And there's the ref. You see that line at the end. Don't please. I wouldn't even applaud that. That's horrible. That line I missed there. It's not good. So I need to just undo that last one. Oh, it undoes the whole thing? All right, I can't live with that. That was not good. No, it should go through that red dot, shouldn't it? Like I said, these are not, even when you have 30, when you have 37 points here, it's still not that easy to go right through. I feel like I'm curling right now. Come on, erase it. Okay. All right, that's. I really did. How do, George? How do I just miss that pole? That's just okay. I'm just. Let's just stop there. Come over here now. All right, that's I can live with that online. All right, that other one, those first two are bad. That's pretty solid. That's good. It's pretty good there. I can't wait to judge yours. I just can't wait. I won't even look at the table. I'm just going to judge the graph the whole time.
I'm gonna cry like a racer probably 4 times. I'm not even gonna finish it. I can't finish the test in the first place. It's like everything.
Got stuck. Ruin a perfectly good Milky Way. All right. Oh, ninth period. There was I don't remember who came up with the first proof. It probably was Frank, to be fair. Half a cardioid? Oh, you did say that too. Oh, good, good.
It was so cute.
Very good.
No, he sent me like half a heart because they complete my cardioid. It was the cutest thing.
That's good. That's nice. I like that. So that's a good math story.
You ruined my story.
Oh, well, because I was upset when you said heart. I don't know what that is. I know what a cardioid is.
Dude, I was like getting there.
Very good. Ow. Anyway, the Milky Way. Somebody did a proof, and somebody made a joke that that's worth the Milky Way. So then I had a Milky Way, threw it to him, and that's been the joke ever since. So whenever somebody comes up with a proof, I just throw a Milky Way at him now. So. Yeah. Huh? All right. The 5 theta one, that one's way messier because you had to graph pi over 30. I'll show you the graph. I ended up doing a lot of work here. I basically solved this like a trig equation. Just I know you need 5 points of 4. So what I did, I found the maximum value here. I just set mu equal to 5 theta and figured out at what angles is it going to hit those points. And and that gives me my 5 tips right there. Because the initial equation was 4 sine 5 theta, so I basically set 4, because isn't that going to be the maximum of this graph? Or negative 4, who cares? Because it could go against the angle, so just pick 4 or negative 4, who cares? Basically solve the equation, when is sine of 5 theta equal to plus or minus 1? So I actually just solved this one out, and that actually gave me the 5 key points, the 5 petals, the tips of the petals, so I knew where I was going to be graphing them at. So I did the 5 theta equals pi over 2 plus 2k pi. Because this is nasty for sure. Pi over 10 plus 2k pi over 5 to graph that, it's just nasty. So if you count by it, my 5 key points are 17 pi over 10, 13 pi, 9 pi, 5 pi, and pi over 10. So one of them was nice, but then the other ones were not. And I started making a table, and everything here is in terms of 30ths and tenths and fifths, which is nasty. So I said, screw that. I said, why not just set this equal to a half now, and then just figure out what thetas give me values of a half. It was still messy, but at least I had another point that I could plot on the grid, which gave me these intermediate points of 2, and then that was enough to get me my my rows. So that's sort of the method I took I haven't shown that way before, but I mean, mathematically it makes sense that if I want to know when it hits the tip, set it equal to the tip, set it equal to the coefficient of 4, and then just solve it from there. Very, very messy for sure. You won't have one that's, you have to graph pi over 30s and 20s and 10s or whatever. So on challenge problems, it will graph on something on this polar grid. No, that would be fun, but no. Like rotate it, that would be fun. Oh, shift it? So let's do some lemniscates.
How is there even shifted? Stupid.
Let's figure it out.
No.
Okay. 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 So I want to start with the lemniscate since that is harder to graph, and that's actually what you're going to do by hand. I did print off some more graphs. We ran out second, so this should be the last sheet, although you might want one for your challenge problems too. You have what? That way, if I get to the, so we're probably gonna do a mini. I wouldn't even call it a quiz, like a Quizlet or like a quiz-ish on Monday, just over 8.1 and 8.2. Can you convert a point? Can you graph a function? So it should be one of my easier quizzes. I just want to make sure, can you convert and can you graph? And then Tuesday you're gonna do a fun. I think it's fun. Thanksgiving themed activity. It's math related, though. It's math. It's math giving. No, nothing. I haven't decided how I'm going to do it. I might do, because there's 6 shapes, I might do 2 graphs per each class. That way everybody gets something different. I haven't decided yet. All right. Let's come back together here. Yeah, so over the weekend, make sure you are studying 8.1, that you can convert points from rectangular to polar and polar to rectangular. Equations, make sure you convert it. Remember, you don't need to graph the equation. You just have to be able to convert it from xy to r theta or r theta to xy. And graphing, that's all we've done in chapter 8 so far. We haven't really done the vector stuff yet, which that's a lot of fun. I enjoy that stuff a lot. Chapter 8's just fun. The whole chapter is really just fun. So I don't care how you make your table. This is how I tend to make mine. Lemniscates. That's r squared. Remember, that's the generic formula. It's r squared equals a squared cosine 2 theta, or r squared equals a squared sine 2 theta. Always 2 theta, and it's always r squared. So I group the r squared and the 2 theta next to each other because that's what I use to evaluate the function. And then, of course, we know by now r theta is what you use to graph the function. That's why I sort of set it up this way. You don't have to set it up this way. I think it makes sense setting it up this way, but I'll leave it to you to make that decision on your own. So cosine, what's a reasonable angle for cosine? Not going to change, pi over 3. And just quick side note for Tuesday, I won't be here. All the geometry teachers are meeting to go over curriculum to get ready for the OST in the springtime. So for Tuesday, yes, the last day before break, I will not be here. None of the geometry, Mr. France won't be, Mika won't be, I won't be, Mr. Christie won't be. Well, he's a department chair. Yeah, that's why he won't be there Tuesday. I feel like I'm missing one. Anyway, there's half the math department will be gone on Tuesday. Algebra 1 did it last week, so they already missed. They did their OST. All right, so what would be, let's just do r squared first here. So if I plug in 0, what's cosine of 0? Still 1, very good. 1 times 4 is 4, so r squared is equal to 4. Next one should be what? 2. So then there's my ratio right there. It shouldn't change. So I'm going by 2s, so it should go 0, -2, -4, -2, 0, 2, and 4. Once you hit the pattern, the table should fly. It really should. Now let's do the theta next here. So theta, of course, just cuts the 2 thetas in half, so it's 0, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Now you're going to see why this is actually enough here. I don't, regardless of the symmetry, too. I don't need to even add in the symmetry of the polar axis as its cosine graph to get the other points. So if 4 is r squared, what's r? That's half correct. Plus or minus 2. So I get 2 points for free. It buy one get one here for points. It's good. It's a good deal. It's a good math deal here. Very good. So r for the next one would be plus or minus root 2. Don't say what. But are they real? That's kind of weird. Okay, interesting. They're a thing. No, and I'll bring up that point in a second. So 0. So what about square this next one? Oh yeah, okay. I was hoping you weren't going to say the square root of negative 2 is 0. I was concerned. dne dne is what you would think, but it's really not. It's really. No, I'm kidding. Yeah, we don't graph those. Yeah, because that's. I'm kidding. Very good. Yeah, we don't graph I root 2's and 2 i's and. Very good. So, yes, this won't be graphing calculator because that would defeat the whole purpose of the graph. If I would know the decimal equivalent of root 2 and root 3, or the 2 I would just know. And do you have to know it to 3 decimal places? No. If you know it to the 10th, you're fine. 1.4, 1.414, so on and so forth, right? And then root 3? 1.7. If there's any other radical that would appear on a test, I would just give you that decimal. If it's a root 5, I'll say root 5 equals 2 point whatever. You just be over 2.4, right? Just 24 squared is 496. So then it'd be just over that. So yeah, root 2 and root 3, I would expect you to know. But other than that, I will give you the decimal if it happens to come up that way. So let's graph this out here. So at 0, I get plus or minus 2. Pi over 3, I get plus or minus root 2. And you're estimating this anyway, so 1.4 is just less than halfway. And then that's 4 pi over 3. Pi over 2, obviously the pole, because we already talked about this has pole symmetry, so that should make sense. And then at 5 pi over 3, it's plus or minus root 2. And I think that's it. Yeah, it's just 2 pi is the same as 0 here. So then my graph that point should probably be a little bit further out there, but I feel like that point, why does that point just not look right to me? Because I graphed the 2 thetas instead of the thetas. Now that's a waste of graphite and rubber, because I graphed the wrong points there. Yeah, and see, yeah, I sure looked at that. I was gonna say that just didn't look. That looked like a really fat. That helicopter would have crashed if we would have graphed that. That would have been bad. That would have had an unequal number of takeoffs and landings. Thank you for getting that, some of you. So at pi over 6 on my plus or minus root 2. Should be, yes. If I would have graphed it right, it would have been an infinity sign. Pi over 4 should be 0 the pole, which is fine. And now we don't graph again until 5 pi over 6 and 11 pi over 6. And then, oh, I forgot the 2 over here for pi. There we go. That's a much safer helicopter right here. It's an infinity symbol. It's a lemniscate, a propeller shape. It's a sideways 8. Really anything works. All right. So I want you to try this one, then r squared equals 4 sine 2 theta on your own. Use that same pattern. Use r squared. Use 2 theta.
Wait, how do you connect the first?
Hold on. I'll go back up here. Yeah. So I mean, graph them in the. Remember, this is connect the dots at the high school level. So start the order in which you did it. Remember, don't fight the hand again. So the hand wants to go down, let it go down, then it curves back up, and then it goes back down. All right. So take a few minutes on that, and I will turn to spirals. All right. So hopefully you chose pi over 6. 0, pi over 6, pi over 2, 5 pi over 6, pi, 7 pi over 6, 3 pi over 2, 11 pi over 6, and then 2 pi, which is useless, but just I wrote it anyway. R squared here, how about 0? This would be 2, right? 4, 2, 0, negative 2, negative 4, negative 2, 0, which means here's my block. That doesn't matter. And theta, or sorry, let's fill out the rest of the r's. Plus or minus root 2, plus or minus 2, plus or minus root 2, 0, 0. And theta is 0. So it is pi over 12, but I mean, it's on the graph, so it still shouldn't be that bad to graph here. I don't need to do, or I need to do this one. These three I don't need to do, and then how about pi? All right, so let's graph the far two columns now. That way I don't goof this up like last one. So we start at the pole. Pi over 2 is plus or minus root 2, so 1.4. Oh, man. Just a rough Wednesday today. Pi over 12, man. Pi over 4 is plus or minus 2. Wait, lost my... And what am I missing here? 5 pi over 12 should be plus or minus root 2 as well. I think it's all the points, right? So it does start at 0. There's your graph. All right, so take a note here that I should point this out in the other graph, really, because I didn't write the thetas in here. So if you notice, at pi over 3, pi over 2, and 2 pi over 3, there is no point here. If I look on this pi over 3 line, there's no dot anywhere on this pi over 3 line. It just curves right in. Same thing at pi over 2. There's no point anywhere on this pi over 2 line because it's undefined. And 2 pi over 3, same thing. There's no point on that 2 pi over 3 line, which would be the same thing down here at, what, 7 pi over 12, 3 pi over 4, and 11 pi over 12. You should not see a dot anywhere on those lines. So even if the graph is in all 4 quadrants, which this one it's not, but this one it is, that still doesn't mean that every angle is defined, as you see from the negative or the negative r values when you try, or negative r squared values. So when you try and square root it, it does not exist. It will if you do plus or minus the square root of, because you're square rooting it, so you have to do the positive square root of 4 cosine 2 theta and the negative square root of 4 cosine 2 theta. Then it should pop up. And the negative? And it still doesn't pop up? Well, the point that's missing is probably because of the domain restriction of some of those angles that the calculator just can't graph at that point. You'll see that in calculus next year when you do some tangent lines, the calculator just goes on the fritz of what it's supposed to do there. I've never tried graphing. I'll take a look at that. I want to hit
Wait, what's like the equation for that?
r squared equals a squared cosine or sine 2 theta. All right, so let's look at the, did we talk about the textbook yesterday or no? Okay, so if you look in your textbook, you'll see e to the theta over 5. So we can graph that now, because that is that's a spiral. So these are completely calculator-based questions, so I don't need to spend, so 8 minutes should really be enough time to solve this out here. So if I graph this r equals e to the theta over 5, we got to really pay attention to the window set and the table set on these problems. Because being able to manipulate your windows is very, very important to see a decent graph here. So if you do a zoom 6 of this graph, I mean, it's not that great. I mean, it looks like the function literally just stops, or the graph just stops, not really the function. So if I look at the window here, it only graphs from 0 to 2 pi, but we need to go way past 2 pi to keep graphing more and more thetas. I tend to go out to 10 pi. I mean, 5 pi, 10 pi, 20 pi. Let it go. Give it some thetas to go by. Now your theta step, if I make this big, say if I make it 2, that's not a very accurate graph. Versus if I make my theta step 0.2, a little bit better. And if I were to make this, 0.05, a really small theta step, you start to see a really clean spiral start to be formed. So the theta step can drastically change your graph if you have a bad theta step. Keep it small. Definitely into the decimals, tenths or hundredths of decimals. But you see how that graph goes off pretty quickly that I can't really see it. So then adjust your x and y. Maybe make your x min, negative 10 should be good for x min. Maybe x max, or actually no, they should both have to be bigger. Maybe I'll make this negative 40. So 40 counting by 8s. And I'll make the y's, negative 40 to 40 counting by 8s. I'm just guessing. I don't know what would be a good window, but I need to give it a chance to get out. All right, that's a decent graph. You can start to see the spiral on that graphing calculator. So how are we going to graph these by hand here? So second window gives you the table set. So I would always start at 0. And what would be a reasonable thing to count by? Go ahead. Because your theta max is probably 2 pi. They change your theta max to 20 pi, it'll keep going and going and going and going. So if we're graphing this on a polar grid, what would be reasonable to count by? What is something that is easy to graph on this polar grid? What angle values? Pi over 6, that's fine. So if I graph by pi over 6, I look at the table here. So let's write this out here. When you're making your table, do not give me a decimal theta. Because if you're counting by pi over 6s, why not just write pi over 6? So it's pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6, pi, 7 pi over 6. After that would be 8 pi over 6, which is 4 pi over 3. Then it'd be 3 pi over 2. Then it would be 5 pi over 3. 11 pi over 6. Now here, 2 pi is actually a different value. Now the radiuses, now these have to be to 3 decimal places, as always. 1.110, 1.233, 1.369, 520. I'm sorry? Oh, you said it. Okay. 1.874, 2.0. So at least we're into the 2s now. 2.311 and 2.566, 2.849. Where do we leave off here? 3.16. And then 2 pi would finally be 3.513. And then just plot these points. So we started, I believe, at 0, 1. Then pi over 6. Now it gets hard to graph this. Is how do you show a difference between 1.1 and 1.2 on a graph? It's very hard to do that. So pi over 3 should be a little bit more outside of that. And pi over 2 a little bit more outside of that. I know it's hard to graph it. 2 pi over 3 a little bit more outside than that. 5 pi over 6 a little bit more. I mean, you get the point here. Then pi goes even further. Now we're finally past the second level here. 2.3 for 4 pi over 3. So once you get past that first level, it really does start to pick up quicker on the r values. 3 pi over 2 is 2.5. 2.8 for 5 pi over 3. 3.1 for 11 pi over 6. And 3.5 for 2 pi. And when you draw your graph, there you go. There's your spiral. And you leave it just like that. It doesn't have to make a complete revolution or you go off the grid. As long as I have a fair number of points, I can start to see that spiral in shape. That's all I need to see. 100% calculator-based problem. So your homework for tonight, what did we leave off with last night? 58 was the last one. Whatever the last one was, then 59 and 62. It's always 4 graphs. So we are finally done with 8.2, one of the longer sections of the year, because we've done this 4 days, 5 days. We've done this for a while. So starting tomorrow, we will start jumping into vectors, 8.3. So it's a lot of fun. Some vector stuff helps you prepare for a little bit of physics and calculus when we start our vector unit. And the airplane problem's coming very quick. Yes, I can't wait. It's a fun problem. So we will start that. Remember, mini quiz on Monday just over graphing and converting on that stuff. So we'll do vectors next couple days, quiz on Monday, Thanksgiving theme activity Tuesday, and then pick up when I see you in December with the rest of the chapter. Yes. After. Either one's fine. Doesn't matter to me. So do it 9.